Okay, this is question 2 from practice assignment 4.2. It says in 2004, a school population was 2,484. By 2009, the population had grown to 3,369. How much did the population grow between the year 2004 and 2009? So we need to, oops, just subtract. So 3369 minus 2484, 885. And so, by the way, this particular problem is kind of trying to walk you through working out the formula for the linear function that has these data points. So that's sort of like what our end goal is going to be. Okay, so 800, oh, goodness. Here we go, 885. How long did it take for the population to grow from 2,484 students to 3,369 students? So this would be then finding the difference in the years. So 2009 minus 2004, which is 5. What is the average population growth per year? So to find it, the population per year, we just divide basically these two that we found. So students, the increase in students or the growth divided by the years. Oops. Years. So 885 divided by 5. So 177, and thankfully that worked out to a whole student. And then with this drop down menu, I think it has like students, years, students per year, or years per student. And since we're dividing the number of students by the years, that would be students per year. Per is like a fraction bar, so per year. Okay. What was the population in the year 2000? So this is trying to kind of get you to figure out the B value, because in number 5, they're going to ask you to find an equation for the population P of the school T years after 2000. So they're going to set that 2000 to be like the 0. So number 4 is going to help us find the B value in the, I guess in this case, it's going to be P equals MT plus B. So we figured out the M in number 3. So now we're going to figure out the B value. And there's different ways to do that. What you might do is kind of think about, okay, well, it's changing by 177 students each year. And it's increasing each year. So if we back it up maybe from 2004, since that's the smaller number, the smaller year, so it's a little closer to 2000. So if we back it up from 2004 to 2000, that means we're going to be decreasing 177 students per year for 4 years to get back to 2000, right? We have to think of going backwards, so we'd be going down. So I would basically just take the difference between these two, 2004 minus 2000, and we get 4. So then the change from the 2004 population to 2000 is going to be 4 times 177. So let's see what that is. Okay, 708. So if we can then take our 2004 population, which was 2484, and subtract 708, that should be the population in 2000. So 708, oh, I'm doing it in the wrong order. Oop. So 2,484 84 minus 708 is going to be our answer. 2,484 minus 708. So 1776. Now I've got Hamilton in my head. Okay. So then our equation, they've already got P equals for us. So our equation is going to be 177T plus 1,776. So then use your equation, predict the population of the school in 2015. So since it said T is years since 2000, 2015 minus 2000 will give us the value of T. So 15 is our T. So we have to then plug into that equation in number 5. So 177 times 15, and then plus 1776. Okay, so 177 times 15 equals plus 1776. So that's a big school. Hopefully they're building more buildings. So 4,431. Okay, so that's that one. So again, it's kind of trying to just walk you through finding the equation, the linear equation given two pieces of data. Okay, so let's look at this next one. So this next one, they're not really going to do the walk you through part, but it's going to be a similar goal. So we've got the following table shows total dollar sales in thousands for a local retailer for various years. Blah, blah, blah. Okay, what was the sales for 2020? So 2020, it was 79,000 right there. How much did the sales increase by each year? So it's kind of, I feel like that's missing a comma, but so what was the increase each year? So since we're in chapter 4, it's probably going to be a constant increase. If you look at from 19 to 34, and then 34 to 49, and so on and so forth, if you look at the difference, it should be the same, because in our table, we're going up 1 year for the years. It's going by 1 each time. And so if we put this into a calculator and look at it, and let's look at the first two. 34 minus 19 is 15. And just to see, so that's the answer, 15 for part B. But just to kind of see, 49 minus 34, also 15. 64 minus 49, also 15. 79 minus 64, also 15. So since it's increasing by exactly the same thing each year, we know that this is linear. This is a linear relationship between the year and the sales. So part C, find a linear function that models the above data. Let x equal 1. This is confusing, okay? Let x equals 1, not x equals 0. X equal 1 correspond to 2016. And let s of x be in thousands. So first off, we need to fill in, they've got a spot for our M and our B. And the M was part B. So we found that. And it's super tempting to put the B as 19, but that's x equal 1. So our B, we actually need to back this up, kind of like in the previous one, because we need to figure out for the B what the sales were in 2015, right? Because x equal 1 corresponds to 2016, so x equals 0 would be 2015. Okay, well, we know that they've been increasing 15,000 each year. So to figure out what we had in 2015, we can just do B equals 19 minus 15 and get 4. So doing it this way where you're thinking of kind of backing it up is just a little quicker, but you could still kind of look at this as like say y equals 15x plus b, and then pick maybe that first point, so 119, right? Because 2016 we're calling that 1, and plug in 1 for x, 19 for y, and solve for b. So you can totally do it that way. It's a little quicker if you think about it this other way. Okay, so then once you've got your equation in part C, you use it to predict the sales in 2021. So again, this is a little bit tricky. I would figure out what X should be by using 2015 corresponds to X equals 0. So 2021 minus 2015 would give us our X. So if you subtract 2016, you have to add one. It's anyway. Okay, so this is going to be, I think, 6. So if we then plug into our function s of 6, 15 times 6, and then plus 4, I think, let's see, 15 times 2 is 30, times 3, I think we get 94. I did that in my head, so I'm not like completely supporting that answer, but I think that's correct. So 94,000. And looking, another way we could do this, by the way, that's 1 year past 2020, so just add 79 plus 15. That's probably actually a little bit easier. Okay, last one was number 6. So number 6 says, suppose the world's current oil reserves is R equals 2,110 billion barrels. If, on average, the total reserves is decreasing by 18 billion barrels of oil each year, answer the following. Give a linear equation for the total remaining oil reserves R in terms of T, the number of years since now. Be sure to use the correct variable and preview before you submit. Okay, so we're supposed to use T. Okay, so our starting amount, or our initial value, that's the B, and they gave us that is 2,110. So that's our B value. That's because we're starting with now. And then we're supposed to be increasing, or I'm sorry, decreasing by 18 billion barrels each year. And I assume we're not going to do, we're not going to actually have billions in there. Like we're just going to go with 2,110 and then just 18. And so that means since we're decreasing, our slope would be negative 18. So we go down 18 each year. So that's going to be, we're supposed to use T, so negative 18T plus 2,110. Okay. 13 years from now, the total oil reserves will be what? So let's just plug 13 into that equation we just found. So negative 18 times 13, and then plus 2,110. This calculator's goofy. I have to do a little minus like that. Okay, and then plus 2,110. Okay, so 1,876. All right. Finally, part C. If no other oil is deposited into the reserves, the world's oil reserves will be completely depleted, all used up, approximately blank years from now. Okay, so we're supposed to, years is T, so we're supposed to find T when R is 0. So setting 0 equal to our function or our equation from A, we have 0 equals negative 18T plus 2,110. All right, so solve in that guy. So subtract. We get negative 2,110 is equal to negative 18t. Divide by negative 18. Divide by negative 18. And that's going to end up being positive. So I'm just going to put in positive 2,110 divided by positive 18. And it said round to 2 decimal places, so 117.22. So hopefully by then we'll have solar and wind and all that kind of thing. So 117.22 years. Okay, so that's it.